Okay, so I want to kind of go over what we did yesterday. First of all, this is going to graph a rational function because it's a fraction. And so yesterday we talked about the zeros and the vertical asymptotes. So where do the vertical asymptotes come from? All right, they come from the bottom. So this would be x equals minus 2. And if you look on the handy-dandy graph that's provided, it already has x equals minus 2 just dotted right in there for you. So next I want to know what the zeros are, and where do I get that? I get it from the top, but is it factored? So we got to factor. So we're going to have x minus 3 and x minus 1. Oops, that's a 1. So that's going to give me my roots, or my zeros, are 3 and 1. And if you look on your handy-dandy graph, those are also provided already, little dots right there. Okay, next, we also talked about the horizontal asymptote. And so the horizontal asymptote, if it was top heavy, it was none. If it was bottom heavy, it's y equals 0. And if it's tied, it was the coefficients. So which one is this? I know, but it's top heavy by how many? 1, which means I get a what? So if we get a slant asymptote, how do I find the slant asymptote? Synthetic division on this one, because there's no leading coefficient and there's no exponent. So when I do that, I'm going to have 1, -4, and 3. And I'm going to test -2. So this is what I get. So where do I get the slant asymptote from that? I get the slant asymptote from right here. Because yesterday we said we don't care about the remainder, right? So what's the slant asymptote? X minus 6. So if you look, that is the slant asymptote. That's the dotted one. It goes through -6 and it has a slope of up 1 and over 1. So here's my slant asymptote. There's my vertical asymptote, and here were my roots. Okay? So the next thing I want to show you just before I go on is when I said the remainder, we don't care about the remainder. We really don't, but I want to show you what it is. The remainder is the distance the function is away from the slant asymptote. So when it says 15, at somewhere on here, it is 15 units away. So the remainder that you get is always the distance that the function is away from the slant asymptote. So that's just a little fun fact that you can go home tonight at dinner and talk about with your parents, that the remainder, after you synthetically divide on the rational function, the distance is the distance away from the slant asymptote, and they'll think you are so smart. I think you're smart. Okay, so I want to go over a couple things then, what we're going to do today. So everything we did yesterday, we had to reduce first. So there is one thing that we're going to do before we reduce, and that's the domain. We're going to, it's the first step before reducing. The domain is the first step before reducing. And so when I'm talking about domain, so if this is my rational function, and these are the asymptotes, and then we have this. That's what it's going to be some form of that. So if this is what it looks like, and I'm asking you for the domain we read left to right. So if I'm reading left to right, what do I have to stop at? Why? What's there? Which one? The vertical asymptote is going to interrupt our domain, correct? So when we're finding the domain, it's going to be all real numbers except, Alyssa, except what? the vertical asymptotes. Okay? So we're going to have all real numbers except for the vertical asymptotes. So the x-intercepts we did yesterday, we're going to do this after reducing and after finding the point discontinuity. And this is the f of 0 of the numerator. So it's the 0 of the top. The y-intercept we're going to find after reducing, after finding the point discontinuity. We're going to substitute 0 in for x, and we're going to solve for y. So the domain is going to be all real numbers except for the vertical asymptotes, and you find it first before you do any reducing. So on number 1, if I want to find the domain on number 1, if we're going to find the domain on number 1, before I even reduce, but I do have to factor. So if I factor, where am I getting vertical asymptotes? So what are they? Here. X plus 2 and x minus 2. So the domain is going to be the x's such that x cannot equal plus or minus 2. So what's the domain going to be for number 2? That's it. And number 3? Very good. Bless you. So an x-intercept has to be written as an ordered pair, so we're going to find the 0. And so where does the x-intercept come from, or the 0? From the top. And we have to check and see if we can cancel anything, because we do this after canceling. So if I factor on bottom, I'm going to get x plus 4, x minus 2. So does anything cancel? No? So my 0 is going to be x equals negative 2. So number 2, we need to factor. So we get x plus 4 and x minus 5. So does anything cancel? The x plus 4, so that's a point of discontinuity. That's not going to give me a 0, but what is going to give me a 0? Positive 5? Mm-hmm. How about number 3? There's no x, right? So when you write that, we write it like this. And we do the little brackets with nothing in it, because there are none. But you can't write none, but there's no real ones. But there are other ones. Okay? So here, can we factor? What does it factor to? What? So nothing cancels, so it gives me the x's of 4 and negative 2. Okay, any questions there? Yeah, that's pretty easy. So next is the y-intercept, which also comes after you reduce. So on number 1, there's no reducing to do. And I find this by substituting a 0 in for x. So I get 0 minus 3 over 0 plus 11. It has to be written as an ordered pair because we're looking for the y-intercept. Yes. So this one, the y-intercept happens after we reduce. So x plus 3, x minus 3. So what cancels? That gives you point discontinuity. I want to know what the y-intercept is. So this is my reduced function. So I get 0 and negative 3. How about the next one? What's 1 divided by 0? Can you do that? Why not? You can't divide by 0. It's an error. You get error. So this is none. And this is okay to write none because it's an actual point. So it's none. Okay, number 4. Can we factor? It doesn't factor. So to find the y-intercept, I just plug 0 in for all my x's. So I get 0 squared minus 3 times 0 plus 11. So what happens to all the 0 crap? It's all 0. And it leaves you with 11 over negative 4.